Hello. So what we've talked about so far is looking at the degree and the leading terms, and what it in math. That's one of the things that's nice is everything builds upon what we've already covered. So we're going to take what we just covered in prior videos and use them to be able to see something cool about our graphs. And what this is called is the leading term test, and it determines end behaviors. So the leading term test, just something to conceptualize on, is in very common sense, but sometimes when we talk about it, it's like an epiphany. As x becomes very small, it approaches negative infinity, meaning that the more negative x becomes, it goes toward a negative infinity. And x becomes very large, or as x becomes very large, it approaches infinity. So the more positive it becomes. With what we're dealing with our polynomials, it is not this simple, but to be able to keep that in mind is that there's also a correlation between the value of x, my independent, and the value of y, my dependent. As I plug in a value for x, I'm going to get something for y. There also depends upon the type of power that's involved and the coefficient that's in front of it. All right, so with that, that leads us to the leading term test. And the leading term test is something very easy to use. You'll use it in college algebra. You will use it in calculus. So this is my leading term, a sub n times x to the nth power. And I have a variety of things I'm going to look at. Really, it deals with the degree. Is it even or odd? And is my leading coefficient a sub n going to be positive, greater than 0? So that's positive, or negative, less than 0. So n is the exponent of the leading term. We're going to look to see if it's even and odd. A sub n is the coefficient of the leading term, and we're looking to see if that's positive or negative. And it goes back up here to what I was telling you about how x is actually affected. If a sub n is greater than 0, it's a positive coefficient. If a sub n is less than 0, it's a negative coefficient. And we need to think about this. Even powers, you always end up with a positive answer because you're taking that number times itself. So even if it's negative, a negative times a negative is a positive. Whenever it's odd, though, you can end up with positive and negative. So make sure that you understand, because if it is a negative number and I take it to an odd power, and let's write that out here. If I say a negative 2 to the third power, what that equals is a negative 2 times a negative 2 times a negative 2. There are 3 negative signs there. That means I'm going to have a negative answer, negative 8. But if I were just to take the positive number 2 and take it to the third power, I would get a positive answer. So this is where we can add positive and negative. Even powers, even powers. So if my n is even, notice that I'm either going to be pointing up in both directions or I'm going to be pointing down in both directions. What delineates that is if I have a negative coefficient. If I have a negative coefficient, it is going to be going in the downward direction. Positive coefficient, I'm going to be going in the upward direction. My power, the even power, will not dictate positive or negative at all. My lead coefficient does for even powers. But whenever I have an odd power, there's a correlation between the sign of my coefficient and the value of x that I'm placing in there. That's why you have it to where it's flip-flopped. This one starts off going down and comes up, and then this one starts up and then comes down. The squiggly line in the middle mean that we don't know what's going on there, but we know the end behaviors because these are the ends of the graph, we'll say, okay, behave in these manners. But in the middle, in the middle, the leading term test doesn't tell us what's going on in there, but we can have a general idea of how our graph is supposed to look. So let's take a look at an example. So again, still dealing with the leading term test and in behaviors, I have a trinomial. This is a polynomial. It is a quadratic equation. The first thing I'm going to do is I'm going to identify the leading term so that I can identify the coefficient and the exponent. So I have a coefficient that is positive and a leading term that is even. So even and positive, that's how my graph should look. It'll be a parabola and it will be going up. Using the leading term test, n is even and 3 is positive, so therefore that's how my graph is going to look. Let's take a look at it. (3x squared plus 6x plus 1). Notice it has the shape. In the middle, I don't know really where it's going to go. I have to use other things, but just my in behaviors, my leading term test, tells me this is the direction of the graph. Okay. Pause the video and see if you can determine what this graph is going to look like for its in behaviors. Okay, first thing to do is identify the leading term. So a sub n, well, x cubed is my highest power, so that's the degree. My leading coefficient for that term is 2, and my exponential power is 3. So I have a positive a sub n and an odd power. Positive a sub n, odd power, so that is how my graph is going to look. It is going to do something like that. And let's take a look at what that graph will be. And there's my graph. And if you notice, it starts off, it rises, we have a max, then we go down and it decreases, we have a min, and then it starts rising again. So this test allows us to be able to determine the in behavior of our graphs. Notes to point out: the domain, which deals with the x-axis of a polynomial, is the set of all real numbers. Your domain is always the set of all real numbers. Every polynomial function of degree n, with n being greater than or equal to 1, has at least one zero, and at most n zeros. Alright, so with that, this is the main thing that you need. You already know how to identify your leading term and how to identify your lead coefficient and the degree of the polynomial. You need to be able to use this little table to understand the in behaviors of your polynomials. Guys, continue to watch your publisher's videos. Critically think and structure your homework. Write everything out. Here's another hint. If you're working your homework problem and you mess it up, you don't erase it. You learn from your mistakes, so write where you went wrong and then rework the problem. If you have any questions, please contact me. Good luck.